Hello, dear students. Welcome for the last session on the chapter The Binomial Expressions. I am Umesh Rajkumar. For this session, you're going to learn about difference of two squares. It is part 3 of this chapter, last part. Let us see the learning objectives. At the end of this session, you will be able to expand multiplication of binomials to obtain difference of two squares. And then you will be able to factorize a difference of two squares. Let us start by expanding x plus 2 times x minus 2. In the first session, you learned that this can be done by two methods. You can do it directly using the distributive law, or using area table. We're going to use the law of the distributive law. X plus 2 times x minus 2. So you're going to take x times x, then x times minus 2, plus 2 times x, plus 2 times minus 2, which is x squared plus 2x minus 2x minus 4. Simplifying the like terms, plus 2x minus 2x, which is equal to 0. Therefore, the final answer is x squared minus 4. What do you observe? You observe that x plus 2 times x minus 2 can be expressed as the difference of two squares. X times x is x squared. X times x is x squared. 2 times 2 is 4. Therefore, if you have x plus 2 times x minus 2, you can do the expansion directly. That is x times x plus 2 times minus 2, which is equal to x squared minus 4. Let us try another example. If you have to expand 2b plus 3 times 2b minus 3 using the distributive law, 2b plus 3 times 2b minus 3, 2b times 2b, then 2b times minus 3, 3 times 2b, and then 3 times minus 3, which is equal to 4b squared, 2b times 2b, 2b times minus 3 minus 6b, 3 times 2b plus 6b, and finally plus 3 times minus 3 is minus 9. You observe that minus 6b plus 6b are like terms. Simplifying, you're going to obtain 4b squared minus 9. Again, 2b plus 3 times 2b minus 3 can be expressed as the difference of two squares, which is equal to 4b squared minus 9. 2b times 2b, 4b squared, 3 times 3, 9. Therefore, 2b plus 3b times 2b minus b can be expanded directly. 2b times 2b plus 3 times minus 3, which is equal to 4b squared minus 9. Thus, a plus b times a minus b can be expressed as difference of two squares. That is a times a squared, b times b squared. This identity is very important. A plus b times a minus b is equal to a squared minus b squared, which is in fact the difference of two perfect squares, a squared and b squared. Let us now see some examples. If you have to expand 3b plus 4 times 3b minus 4, now we're going to do it directly using the identity a plus b times a minus b is equal to a squared minus b squared. Therefore, the solution, 3b plus 4 times 3b minus 4. Here, you can replace a by 3b and b by 4. Okay? That is a by 3b, b by 4, which is equal to a square minus b square. That is 3b to the square minus 4 to the square, which is equal to 9b square minus 16. Let us try another one. Expand 5y plus 9z times 5y minus 9z. You're going to use a plus b times a minus b is equal to a square minus b square. So directly 5y replacing by a, you're going to replace a by 5y and b by 9z, which is equal to 5y to the square minus 9z to the square. And the final answer is 25y square minus 81z square. Let us do an application. Use expansion of a plus b times a minus b is equal to a square minus b square to find the value of 93 times 107. Observe, 93 can be written as 100 minus 7, and 107 can be written as 100 plus 7. Okay? It is in the form of a minus b times a plus b. And you know that a minus b times a plus b is equal to a square minus b square. Therefore, it can be written as 100 to the square minus 7 to the square. 100 to the square minus 7 to the square is equal to 10,000 minus 49, which is equal to 9,951. Now, we're going to see what we call factorization. If we take a plus b times a minus b, it can be expressed as the difference of two squares, that is a square minus b square. This is called expansion. Now, if you're going to do the reverse process, that is a square is equal to a plus b times a minus b, this process is called factorization. That is, you're going to write it in terms of bracket now. A square minus b square is equal to a plus b times a minus b. Examples. Factorize x square minus 25. 25 can be expressed in index form. 25 can be written as 5 to the square. Therefore, x square minus 25 is equal to x square minus 5 to the square. It is in the form of a square minus b square. Factorize, put in bracket, you're going to replace a by x and b by 5. So the answer is x plus 5 times x minus 5. Or you can write x minus 5 times x plus 5. Do not forget that multiplication is commutative. Second example, m square minus 16 over 81. 16 over 81 can be expressed in the form of 4 over 9 to the square. Therefore, m square minus 16 over 81 is equal to m square minus 4 over 9 to the square, which is equal to m plus 4 over 9 times m minus 4 over 9. Factorize completely. See the word completely. 5x squared minus 500. This word is very important. Okay? Here, you have to take out any common factor first. You have common factor here. The common factor is 5. So, removing 5 outside, you're going to obtain 5 bracket x squared minus 100. You can check it. 5 times x squared is 5x squared. 5 times 100 is 500. Therefore, this is also factorization, but you are told to factorize completely. So, x squared minus 100 can be written in the form as x squared minus 10 to the square. Now, x squared minus 10 to the square, it is in the form of a plus b times a minus b. Therefore, the final answer is 5x plus 10 times x minus 10. Let us now try an application. Without using a calculator, evaluate 9.8 to the square minus 0.2 to the square. 9.8 to the square minus 0.2 to the square is in the form of a square minus b square. Therefore, it can be expressed as a plus b times a minus b. 9.8 plus 0.2 times 9.8 minus 0.2. Simplifying, 9.8 plus 0.2 is 10. 9.8 minus 0.2 is 9.6. Multiplying, you're going to obtain 96, which is the answer. Evaluate 2 over 7 to the square minus 4 over 7 to the square. Again, it can be expressed in the form of a plus b times a minus b. Therefore, it is 2 over 7 plus 4 over 7 times 2 over 7 minus 4 over 7. 2 over 7 plus 4 over 7 is 6 over 7. 2 over 7 minus 4 over 7 is minus 2 over 7. Multiplying, you're going to obtain minus 12 over 49. Factorize x plus 2 to the square minus 9. Okay, here you observe that it is in the form of a square minus b square. The 9 can be expressed in index form as 3 to the square. Therefore, x plus 2 to the square minus 3 to the square is x plus 2. The x plus 2 can be replaced by a, and 3 can be replaced by b. Therefore, a plus b times a minus b. 2x, x plus 2 plus 3, this is a plus b, a, x plus 2 minus b. Simplifying, we are going to obtain x plus 5 times x minus 1. Some exercises for you to practice at home. Expand and simplify. X plus 3 times x minus 3. X plus 0.8 times x minus 0.8. X plus 1/4 times x minus 1/4. 3x plus 4 times 3x minus 4. X plus 5 to the square minus 169. Evaluate 103 times 97. 5.2 to the square minus 0.5 to the square. 5 over 9 to the square minus 2 over 9 to the square. Let us summarize what we did today. You have learned about expansion of perfect squares. You have used the identity a plus b times a minus b is equal to a square minus b square to expand perfect squares. You have learned how to factorize a difference of two squares. And finally, you have learned some applications. This is the end of this chapter. Dear students, we have now come to the end of this chapter. I hope that all your doubts have been cleared and look forward to see you soon. Thank you and goodbye for now.